Hello and welcome. Today I will show you how I would set up my React project. Think of it as an investment. We will spend some extra time before we start the actual coding, and in return we will get beautiful bug-free code that's very easy to work with. So you can focus on creating a great app instead of wasting your time and energy on stupid bugs. To get started, I want you to know that plain JavaScript sucks. Luckily, TypeScript comes to the rescue. If you only know JavaScript, don't worry. It's easy to switch to TypeScript. Just check out how types and interfaces work. And we will also use a linter, specifically eslint, to test our code for typos and help us to avoid stupid mistakes. It will also force us to format our code nicely. The force is critical here, because I am lazy and so are you. If they would just throw a warning, we will skip it after a while. But they throw actual errors, so you have to write clean code, which is excellent. First of all, let's create a React project with a TypeScript template. I will open my VS Code in this newly created folder. And we will also install all the packages for eslint. There are a few of them, so check out the description and copy them if you are following along. Now we will create an eslint source file and paste some stuff in it. You can read about what these things do. You can also just copy them. The only things that are pretty important are these rules. Here, you can specify what should eslint check for in your code. I usually use pretty strict settings, but sometimes TypeScript and eslint rules overlap. Then don't panic. Eslint will tell you which rules you are breaking, and you can come in here and turn it off. But don't abuse this. The fewer rules you turn off, the cleaner your code. You should also download the VS Code eslint extension. And add this to your settings.json file. Voila, now eslint is the default formatter. Now we can go into our package.json and remove these 4 scripts. We don't need them. We add 2 new scripts, lint and fix. Lint will make eslint check our code for mistakes, and fix will fix all the mistakes it can. Don't worry, it won't mess up anything. If it's unsure how to fix something, it will skip it. So let's check them out. As you can see, lint found 36 errors. And fix could fix almost all of them. If you use VS Code, it will run the fix command when you press the format shortcut. So you probably won't use this command line tool. I just showed you so you know what's happening behind the scenes. Now let's get some code running. We are going to be using Webpack, which will do a lot of magical things. It will bundle our code, optimize it, turn TypeScript into JavaScript, etc. It will also act as a development server. Let's install all the packages that we need. And this script will also work if you have JavaScript in your project. If you don't, you can skip the Babel part, but I don't think it will hurt you if you have it there. If you have JavaScript, you must add this Babel source file and paste this into it. Now we have to change the Tsconfig file. This out there is pretty important. Here will the build code go. I usually use 2 webpack files, one for development and one for production. Let's name them webpack.dev and webpack.prod, and I will paste some stuff into them. The development one focuses on having a fast build to see your changes faster. The production one takes longer to build, but should be more optimized. Once again, you can read about all these things later. You don't have to understand everything to create great stuff, but regardless, keep learning. Now we can add 2 more scripts to our package.json, dev and prod. Prod will make your production build, and dev will start your development server. So let's run dev. After it finishes building, we can see your app in the browser. It does have live reloading, but it doesn't always work, so it's safer to refresh manually. Let me remove some stuff that we will not use so they don't distract us. At this point you will already have very few bugs, because TypeScript and eslint usually catch them. Now we create a folder named components. You guessed it, here will all the components go. I make a separate folder for bigger components. In this folder I make another folder for all the subcomponents, and a file for the component that will glue all the subcomponents together. You can get creative with how you separate your stuff. Just have rules so you know where to search for things. It will make your life easier in the long run. I always use a UI library, so I will install Material UI. Let's create our count component. All React components return a jsx.element. For now, it will just be some text. We will also import it at app.tsx. Now let's create two subcomponents, buttons.tsx and count.tsx. I will just copy this real quick and change it up a bit. Let's also import them into the big component. I will copy some nice buttons from the Material UI documentation. I also dug around in the docs and styled the components a little, so it's easier to see what's going on. I forgot to change the name of the count component, so please ignore that. Now let's talk about the next big thing we are going to use, which is Redux. First, we should talk about the problem that it solves. In React, we are working with state. If I use useState in one of the components, the component will re-render each time the state changes. I aim to increase and decrease the count when I press these buttons. Without Redux, we will have to lift the count state to our big component. So let's do it. I will import useState and create a state called count. We also have to create two functions, one that increases and one that decreases this state. If you call these functions from another component, they will still change exactly this count state. JavaScript functions are very interesting. Let me know if you want a video about how they work. Because we are using TypeScript, we need to create interfaces for these props. A little extra work that usually saves us from hours of debugging because we pass the wrong props to the component. The buttons component will await two props, both functions that take 0 parameters and return void. And the count component will just await a count, which is a number. Then we pass the count state to the count component and the functions to the buttons component. Finally, I have to hook up these functions to the buttons and in the count component I will just display the count. And only now we can update the count. This kinda sucks. As a React project grows, it will look something like this. The problem is that we can only pass down the state from the parent component to one of the child components. So if this component is a button, and we want to change something in this component when the button is clicked, without Redux, we would need to lift the state to their first common parent, create a function that changes the state, and pass this function down to the button, and also pass the state that we are changing to this component. So you will want to use a state management library like Redux. Redux creates a separate place where we can store all of these states. Each component can access this state, mutate it, and will get re-rendered if one of the states he uses changes. It's excellent, but there are a few things to watch out for. First, old school Redux needs a lot of boilerplate code and complicates things. So definitely use this new thing called Redux Toolkit. It's a newer version of Redux, needs minimal boilerplate, and is much easier to use. And also, when I learned about Redux, I was amazed, so I smashed every single state in it. But this is not the way to do it in my opinion. You should only bring the global state into Redux. So when you create a component, think through which state will only be used in this one component, and use useState on that state. For example, the current position of a floating panel should be stored in a useState, unless the whole app changes depending on this position. But suppose you are fetching some essential data. In that case, the whole app should change depending on whether the data is currently being fetched, has arrived successfully, or there was an error. So you should create a state called fetchState in the Redux store and set it to loading, success, or error depending on how the fetch is going. With some experience, you can tell which states should go where. So let's install all the packages that we need. We will create a file in the source folder called store and write some config stuff in it. Redux Toolkit has very good documentation with React, so read about what these things do. We will create another file called hooks and paste some stuff into it. From this file, we will export use-app-dispatch, which we will use to mutate the state in the store, and use-app-selector, which we will use to select data from the store. With Redux Toolkit, you create things called slices, which splits the whole state into slices. You will have to think about how to slice up your store and ensure that related states are grouped together in one slice. Let's create a folder called reducers and in it a file called counter-slice. I will write some boilerplate stuff. This naming is pretty important. We have to define the initial state, but TypeScript is not happy because we must determine a type for it. So let's create a new folder called types. In it, we will create a new file called counter-slice types. From this file, we will export an interface called count-initial-state, which will have one member called count, and it will be a number. Now I will import this interface and use it. As you can see, TypeScript nicely tells me what I am missing. I will create two reducers called increaseCount and decreaseCount. And I will export them as actions. Don't worry about all these fancy words, just copy them. The only thing that you need to know is that the only way you can change a state in a Redux store is through a reducer. In the store I will register this slice. And in the index file, I will have to wrap my whole app in this provider component. I will delete the ugly EU state solution. Now I can use Redux in my components. I will hook up the increment and decrement count to these buttons. I have to set dispatch equal to the return value of use-app-dispatch and use this to call the function. Let's create another file called count-selectors. Create a selector which selects the count. Notice how I created a separate file for the selectors. More on this later. Now I will use the use-app-selector hook and select the count. And voila! I know this seemed more complicated than the use-state solution. But as I said in the beginning, this is an investment, and in the long run it will make your app so much better. One more package that I often use, but I can't show it to you because the video would be too long, is Redux Persist. It basically caches everything that's in the store in local storage. It makes client-side caching very easy. I will leave a link in the description to how to set it up with TypeScript. I will also quickly show you how to set up navigation. We have to install React Router DOM. We come to index.tsx and wrap our whole app in the browser router component. I will create a new component just to show you how this routing works. Then we come to app.tsx and import link, routes and route. We wrap our route components in one routes component. Let's set the default route to our count component and create another route to the new component. We also have to import this new component. Now we can visit this URL. Let's add links and we can switch between routes now. So simple. Now let's talk about one of the most important parts, API calls. I found this API that returns 10 random jokes. I want to be able to get these 10 jokes and display them. I will need Axios for it, so let me install it. Redux Toolkit has this thing called Create Async Tank, which is a tool that gives a really nice workflow to API calls. You will see what I mean in a second. Here, this naming is essential. The first part is the slice's name, and the second is the function's name. At this point I made a stinky mistake. Make sure that you only return result.data without the brackets. Really don't know why I wrote it like that. Probably autocomplete pranked me. And I will create a thing called extra reducers, and I will add 3 cases: pending, fulfilled and rejected. If you look past all these complicated words, it's pretty simple. If you make an API call, first you will wait until the server responds. So whatever you put in pending will get executed at the moment when you make the call and start waiting. If the server responds successfully, this code will get executed. If it responds with an error, this code will get executed. Let's add an enum to the initial state called fetchState. This can be loading, success or error, and I also like to add initial. Go back to the slice, and initially set fetchState equal to fetchState.initial. In pending to fetchState.loading, in fulfilled to fetchState.success, and in rejected to fetchState.error. Let's import this function into my component and hook it up to a button. As you can see, TypeScript tells us that we need to use then and catch. I will open Redux DevTools to see what's happening. Initially, fetch state should be 3. When I start fetching, it should jump to 0, and then to 1 or to 2, depending if the call was successful or not. Works like a charm. Now I want to display the data that we get. A joke has a setup and a punchline, so let me create a type called joke. And the initial state will have a member called jokes, which will be an array of jokes. Now in fulfilled, I want to extract the setup and the punchline from each joke and set it equal to jokes. Here this also should be different because of the mistake I made earlier. I will create another subcomponent, let's call it data. I will also install React ID generator, because I will use map on a list, so I have to specify a unique key. Let's quickly import the data component to the big component. I will also create 2 selectors. One will select the fetch state and the other one the jokes. And I almost made a mistake. Make sure you name your functions well. I will import a bunch of stuff that I will use in just a second. And select the jokes and the fetch state with use app selector. I go to the Material UI site and copy this loading indicator, error message, and list. If it's loading, I want to show the loading indicator. If it's an error, I want to show the error message. And if it's successful, I want to display the jokes. If it's initial, I don't want to show anything. Ta-da! Let's change the URL to an invalid one. Everything works like a dream. So yeah, if you follow this, you can create a pretty cool app without much effort. Now let's take things further and talk about some performance stuff. Let's say I want to count how many letter A's are in these jokes. First of all, don't do it in your component. Remember that you created a separate file for the selectors? The goal is that the component gets pure, ready-to-use data, so you only worry about the UI in the components and mess with the data in the selectors. I will need to create a function which counts the number of A's. For that I will use Lodash. It's a library that has a bunch of utility functions. It's really practical, and these functions are much more tested and optimized than yours will be, so have the docs open and use them whenever you see an opportunity. I will come back to Lodash a little later. I will use join, concat, and filter, so I will import them. Don't do the import underscore thing. Do it like this. I will whip up an algorithm that counts the number of A's. We can display it. And it works. But we have an issue here. This function is expensive, and if I console.log something each time it runs, you can see that it calculates each time the component re-renders, which is a colossal waste, because the actual input only changes when we fetch new data. Luckily, Redux Toolkit has this thing called create selector. You pass one or multiple selectors to it and a function, which will get the result of these selectors as a parameter. And now, this function will only run when the result of this selector changes. It will cache away the result of this function and return it each time it is called with the same parameter. And as you can see, it only ran twice, when we had no data at the beginning, and once we got the result of the API call. But only use this on expensive functions, where the value of the input selectors don't change often. If you use it on a function who always gets called with a different parameter, it will actually worsen the performance, because it will just have to store a lot of unused cache. Let's get back to Lodash. There are 4 functions I want to highlight: memorize, debounce, throttle, and isNil. I have an in-depth video about debounce and throttle, so check it out. It can make a huge difference in your app. IsNil just returns true if it gets undefined or null. It's very basic, but it's really practical for conditionals. And memorize caches the value of a function away. Just like the previously mentioned create selector. In my projects I usually have to calculate, filter, or sort something, and I create a separate folder for these bigger algorithms. For example, let's create a function that calculates the factorial of a number. And I display the result in a component. Now the same thing as with the selectors. It will run each time the component re-renders. But if I wrap it in memorize, it fixes it. The same things apply as with the create selector. And huge warning, only works for functions with one parameter. If your function has multiple parameters, check out the docs. I will wrap things up here. Don't be overwhelmed, you can slowly adopt these things one by one. I hope you found this video helpful. If you did, smash like and subscribe so you don't miss out. If you have some personal best practices, feel free to share them in the comments. I will be happy to discuss them with you. See you next time and keep on improving. Bye.